Preliminaries. In this section, we review basic properties of truthful mechanisms. We will place two standard assumptions on our mechanisms. The first, that they are individually rational, means that no agent has negative expected utility for taking part in the mechanism. The second condition we require is that of no positive transfers, which restricts the mechanism to not pay the agents when they do not win, i.e., xi equals to 0 implies that pi equals to 0. In general, we will allow our mechanisms to be randomized. In a randomized mechanism, xi is the probability that agent I is allocated the good, and pi is agent I's expected payment. Since xi and pi are outputs of the mechanism, it will be useful to view them as functions of the input bits as follows. We let xi of b, pi of b, and ui of b represent agent I's probability of allocation, expected price, and expected utility, respectively. Let b minus I equals to b1, b2, and so on, until bi minus 1, bi plus 1, and so on until bn represent the vector bits excluding bit I. Then, with b minus I fixed, we let xi of bi, pi of bi, and ui of bi represent agent I's probability of allocation, expected price, and expected utility, respectively, as a function of their own bit. We further defined the convenient notation xi of bi b minus I equals to xi of b, pi of bi b minus I equals to pi of b, and ui of bi b minus I equals to ui of b. Definition 13.5. A mechanism is truthful in expectation if and only if for all I, vi, bi, and b minus I, agent I's expected utility for bidding their valuation, vi, is at least their expected utility for bidding any other value. In other words, ui of vi b minus I is greater than equals to ui of bi b minus I. For single-parameter agents, we restate the characterization of truthful mechanisms, which was proven in Chapter 9, Section 5.6. Theorem 13.6. A mechanism is truthful in expectation if and only if for any agent I and any fixed choice of bits by the other agents b minus I. 1. xi of bi is monotone non-decreasing. 2. pi of bi equals to bi times xi of bi minus the integration of xi of z dz integrating with z starting with value 0 to value bi. Given this theorem, we see that once an allocation rule x dot is fixed, the payment rule p dot is also fixed. Thus, in specifying a mechanism, we need specify only a monotone allocation rule, and from it, the truth-inducing payment rule can be derived. It is useful to specialize Theorem 13.6 to the case where the mechanism is deterministic. In this case, the monotonicity of xi of bi implies that for b minus I fixed, there is some threshold bid ti such that xi of bi equals to 1 for all bi greater than ti and 0 for all ti less than pi. Moreover, the second part of the theorem then implies that for any bi greater than ti, pi of bi equals to bi minus the integrations of dz integrating starting with value equals to ti to value equals to bi. And the results of the subtraction is equals to ti. We conclude the following. Observation 13.1.1. Any deterministic truthful auction is specified by a set of functions ti of b minus I, which determine for each bidder I and each set of bids B minus I an offer price to bidder I such that bidder I wins and pays price TI if BI is greater than TI, or loses and pays nothing if BI is less than TI. Ties can be broken arbitrarily.